Hey guys, we are studying for our geometry test. That will be this Wednesday, March. Hold on. 30th.
And your incentive will be no fooling April Fool's Day, Friday, April 1st.
Yes. Okay, so let's get started. So the first one says, which set of angle measures cannot, I was white, that probably won't work, cannot be the angle measures of a triangle. So I know when I have a triangle, all the angles in a triangle, when I add them up, must equal 180 degrees. So I'm looking for the one that is not a triangle. So there's going to be 3 of them that equal 180 degrees and then 1 that's not. So let's go ahead and start adding these up. The first one I've got 58 plus 60 plus 62. I'm going to go over here and do some math. I've got 58 plus 60. 8 plus 0 is 8. 5 plus 6 is 11. Add that 62 in. 8 plus 2 is 10. Carry my 1. 1 plus 1 is 2. Plus 6 is 8. Oh, looks like that is 180. And we are really tempted to pick that answer, but again, we're looking for the not. So that's not it. Okay, the next one I've got decimals, our favorite. I'm going to add them all up. I already know. I'm going to pretend there's no decimals here for just a second. I know that if I have an equilateral triangle, I know that 60 plus 60 plus 60 is exactly 180. But then I've got to add these 0.5s in, and I know 0.5 plus 0.5 is 1 whole. So this is going to be 181. So that's too big. So this looks like this is probably my answer. I'm going to go through and check just to make sure. When I add these up, I've got 15.5 plus 34.5. And notice how I'm lining up my decimals, okay? Adding, subtracting, we got to line them up. So 5 plus 0 is 10, okay? Bring my decimal down, and they stay lined up, just like this. Okay, bring my 1 up here. 1 plus 5 is 6, plus 4 is 10. Carry my 1. 1 plus 1 is 2, plus 3 is 5, plus 3 is 8, and then, so that is 180. And even though it has that 0.0, we really don't need that 0.0. It doesn't change our value, so it is 180. Which again, we're looking for something that's not 180. Last one, this is probably the easiest one. 30 plus 50 is 80, plus 100 is 180. So again, that's not our answer. So our correct answer would be B.
All right, number 2, Ashley drew a triangle, ABC. If B is 45.5 degrees, what is the measure of angle A? Well, I know that when I add all the angles of a triangle, it equals 180 degrees. And I also know that this little guy in the corner right here is 90 degrees.
How'd you know that, Miss Kemp?
Because a right angle, which is what this is indicating, equals 90 degrees.
Oh.
So I'm going to take 90 degrees plus angle B, which is 45.5.
How'd you know that?
Because it told me in the story.
Oh, so we probably shouldn't skip through the word problems and just look at the picture,
Yeah.
because it has important information.
I should highlight that. Did I do it?
There you go.
I did.
You did it.
I did it.
Woo-hoo.
Okay. So when I'm adding these, I'm putting in a decimal. I want to keep those decimals lined up. So 90 plus 45.5. So my decimals are all nice and lined up. 0 plus 5 is 5. 0 plus, or decimal plus decimal is decimal. 0 plus 5 is 5. And 9 plus 4 is 13. So
I see it. There's my answer.
No.
My answer.
This is not our answer because we need to subtract from this 180 degrees. So I'm going to add a decimal to this guy right here. And I'm going to put my 135.5 under there. And I'm subtracting to find my missing angle. So it's 2 steps. First you add, then you subtract. So I can't do 0, take away 5. I go next door, nothing's there. I regroup. This becomes a 10. I make it a 9. This becomes a 10. 10 minus 5 is 5. Decimal minus decimal is decimal. 9 minus 5 is 4. 7 minus 3 is 4. And 1 minus 1 is 0. So I'm looking for 44.5 degrees A. 44.5. 2 steps.
2 steps. Okay, number next. The lengths of 3 line segments are shown. So I've got 2.5, 4.5, and 6.5. So it says which statement about these 3 line segments is true. I'm trying to figure out if these can form a triangle. So remember with our pencils, we tried to figure out, could I always form a triangle? So we always take our 2 smallest sides, which in this case is going to be 2.5 and 4.5, and we're going to add those together. So when I add, again, when adding decimals, I got to line them up nice and neat. Okay, 5 plus 5 is 0. Carry my 1. Bring down my decimal. What?
Decimal. Good. I remember the decimal.
Yes. 2 plus 4 is 6. Plus 1 is 7. And again, do I really need the 0.0?
No,
not so much.
It doesn't change the
So this is 7. So I got to look at my third length. If this is bigger than 7, if this is bigger than 7, then this will work. But if it's not, then it's not going to work. And 6.5 is smaller than 7. So this is not going to form a triangle. So I'm going to go through and look at my keywords here. So I've got cannot form a triangle, can form a triangle, cannot form a triangle, and can form a triangle. So I'm going to go ahead and cross off all the cans because I know it cannot. Okay? So this says the line segments cannot form a triangle because the longest side of the triangle must be longer than 6.5 inches. And C says the line segment cannot form a triangle because at the least 2 sides of the triangle must be the same length. Well, this has nothing to do with it. And A is true, right? It has to be longer than 6.5. If it's not longer than 6.5, it's not going to work. So A is the true statement here.
Awesome. Okay. I love how Ms. Neal says, and question next. Okay, we're looking at an outline of a yard shaped like a trapezoid is shown in with its dimensions. Which equation could be used to find A, the area of the yard? Okay, so I'm going to look at my handy dandy reference materials to find area of a trapezoid. And on that it says area equals 1/2 base 1 plus base 2 times the height. Let's good at this as you are. Okay, so I'm looking at my picture and reading in the story, I don't have the area, so I'm going to keep the letter A. So I do not know what the area is. Under 1/2, I'm going to write 1/2 because we need that. Under base 1, B1, I'm over here looking at this. This is base 1, so I'm going to put a 15.
Miss Kim, would it matter if I said base 1 was 12?
It would not matter because when we add those two, it's still going to be the same.
Commutative property, either way.
Base 2, I'm going to say is 12. And then my height is missing. I don't know my height, but it does have this X right here. So I'm going to say my height is X.
Why is it not Y?
Because these are no-no numbers.
Ooh.
We do not touch these no-no numbers because they are slant heights, and we do not need slant heights.
So can we go ahead and cross off the ones with Y's in them since they're no-no numbers?
Oh yeah, let's do that. So we could get rid of A because it's using a no-no number.
Bye.
B's doesn't have any no-no number. C's got a no-no number.
Bye, C.
And D doesn't have any. Okay, so I'm looking at what I've written and I'm looking at my answer choices. And this appears to be exactly like this, except they've got 12 plus 15 and I have 15 plus 12, but you and I just said that that was okay because of the commutative property. I'm going to say D is correct because B, we're not halving 12, we're halving 15 plus 12.
Yeah, we got to do our VIP, parentheses first, always.
Yes, Jim Doss would have helped me there.
Okay, number next says, which equation shows one way to find the volume in cubic feet of a rectangular prism. So again, when I look at my formula chart for volume, there's only one thing there because we only find volume of rectangular prisms in 6th grade. And when you look, your formula chart's going to say V equals big B times little h. And a lot of times 6th graders get confused. I know today on the warm-up, we were trying to do 2 numbers, but when we have volume, it should always be 3 numbers. We've talked about how when we see a capital letter like this big B, we're not just plugging in one number, we're plugging in an entire formula. This big B stands for area of the base. So that's really area of a rectangle because it's a rectangular prism.
And I tell my students that big B is kind of like your mama. Your mama's so fat she rolled over on $1 and made 4 quarters. We say the base is so fat that it needs 2 numbers under it. Your base is so fat it needs 2 numbers.
I love that, Miss. That's great. So to find it, we're going to do length times width, or I know on your formula chart it says base times height. However you want to say it, we learned that those 2 things mean the same thing. So again, your mama's 2 numbers now.
The base needs 2 numbers.
Okay, so length, width, and a height, which we have. So if I look here, my rectangle's got a length of 6. It's got a width of 5. And then it's got a height of 4. So again, I'm multiplying all 3 numbers. And again, multiplication is commutative, so would it matter if I had it in a different order? No, you could multiply in any order and we should always get the same answer. So I just need to make sure that all of my signs are multiplying. So if I look at A, these are both adding. That's out. We're multiplying. If I look at B, multiply, multiply. That looks right. So question mark. C, I've got an addition. That's wrong. But the multiplication there is right, but still wrong. And then again, this one's got multiplication, but it's got this plus sign, so that's a no-go. So the only one that works is B. Multiply all 3 numbers.
Okay. Question number next. Okay, which of the following equations can be used to find the area of this right triangle? So I'm looking at my handy-dandy reference materials, and I find the word triangle, and I see this formula. Area equals 1/2 base times height. Okay, so using my picture over here, this picture can be kind of confusing. They just want the triangle, the shaded part here. They don't want the whole rectangle. The diagram's just reminding me that triangles are half of a rectangle. So I've already got that 1/2 in my formula. I'm going to copy that down. Area equals 1/2. And my base, or B, is right here. For U, it tells me U means units. So under the B, I'm going to put a 4. Under the H, I'm looking at the height, and this is my height over here, 1, 2. So I'm going to say 2. I'm missing something. Do you know what I'm missing, Miss Neal?
Parentheses.
I am.
Looks like 42.
We don't want 42. We want 1/2. We want 4, and we want 2. Okay, I get a choice here. I can have 4, I can have 2, or I can do 4 times 2 and half that. It's all about commutative property, and I can do these in any order. I'm going to have 4, which gives me 2, and 2 times 2 gives me 4 units squared. But I went way too far. I didn't even have to do all that. I should look at my answer choices. Which answer choice matches what I have? Well, A has 1/2. I need that. It has a 2. I need that. And it has a 4. I need that. And it's multiplying them all. Okay, B has a 1/2. Oh, but it's got it 2 times. I don't need 1/2.
They went half and crazy.
Don't go half and crazy. So I'm going to get rid of that. C does not have the half. Oh, no. They forgot the half. And then D does not have a half. I'm getting rid of D. So my answer is A.
Okay, number next. What is the area of the trapezoid? Whoop, whoop. So it even tells me, how nice are they, shown below. Okay, so my shape is a trapezoid. I'm going to do our strategy. Nick Foster's silly self. Okay. We're going to name it, which they already did for me. It's a trapezoid. If I look on my handy dandy formula chart, the area formula is A equals 1/2 base 1 plus base 2 times height. Again, that is on your formula chart. You do not have to have that memorized. Then my first step is I get to substitute. So first I'm looking for base 1. I'm going to say base 1's 15, but if Miss Kemp said it was 23, it doesn't matter. We're both right. So we're going to put 15 here for base 1. Then I've got base 2. That means my base 2 is 23. And then lastly, my height, again, it has to touch both bases. Just like when you measure me, it's got to go from base to base, top of my head, bottom of my feet. Okay, so then I'm going to bring everything down nice and neat. My half, put my parenthesis in there, my addition sign, my other parenthesis. So again, when I solve this, I got to use GMDOS.
Oh, yeah.
Okay, I can't start halving yet. I've got to get rid of these parentheses. I've got to add what's in here. Always, always, always. And 15 plus 23 is 38. Bring it all down, make it pretty. Okay. And I think I'm going to half first. I think I want to half the 38 and make it smaller. So I'm going to go ahead and take half of 38. And I'm going to say that is 7 and
19?
Is that 19?
19.
19. Okay, 19. And then again, I still have the 9 I'm going to bring down. Now to find area, all I have to do is 19 times 9. 9 times 9 is 81. Carry my 8. 9 times 1 is 9. Plus 8 is 17. So area equals 171 units squared. So let's look and see. Oh, look. There she is.
Letter C. 6th grade, I'm looking at your test, and the shape is not named on the test. So you need to recognize that that is a trapezoid. Think about that red pattern block from when you were in elementary school. We think about a skateboard ramp or the top of a house, like the top of a birdhouse for trapezoid.
Yeah, so remember, parallelogram has to have 2 sets of parallel sides. These right here are not parallel. If I keep drawing them out, notice what's going to happen. It's going to cross up here. It can't be a parallelogram. And a triangle only has 3 sides. This has 4 sides. So that's a trapezoid. Thank you, Miss Kemp.
All right. So our next question here with George. George is making a flag in the shape of a triangle. So we're talking about a triangle. What is the area of George's flag? So I need to do better with my N, F, S, S. So I'm naming the shape, and I said it is a triangle. Okay, I'm going to look at my formula chart, and it says area equals 1/2 base height. Okay, my S is substitute, so I don't have the area. I'm going to keep the A. I need this 1/2. But for the B, I'm going to substitute my base. So I go over here to my picture. My base is 20. So under the B, I'm writing a 20. And then underneath my H, I'm writing the height. And that goes perpendicular to the base. So here's my height.
Which means it forms a right angle.
Well, yes, look at that 90-degree symbol right there. So I'm doing 8. So I go over here under H, I'm putting 8. And I have to have parentheses. Okay, I'm going to half 20. I know that half of 20 is 10.
That's a good one.
And then 10 times 8 is 80. So my area is 80 meters squared. Looking at my answer choices, D, 80 square meters is the same as 80 meters squared. Yay!
Yay!
Question next.
Oh, we got another volume one. Okay, the dimensions of a cardboard box is shown. What is the volume of the rectangular prism? So they already drew me a pretty picture. Again, I'm going to be doing my strategy. So Nick Foster's silly self. Well, the name of the shape is a rectangular prism, they told me. When I look on my formula chart, remember, it's going to tell you V equals big B H. But we know that the big B, like Miss Kemp said,
your base is so big.
But we got to give it 2 more letters. So this really is equal to these 2 letters here. So I'm going to use that formula because I like it better. So volume equals length times width times height. Then I get to start plugging it in. So my length, I'm going to say, is 22.
Good parentheses, Miss Anne.
Thank you. My width is 5.5. And my height is 7.5. So now I get to start multiplying. So I'm going to...
Let's do the 2 decimal numbers.
You want to do the 2 decimals? Okay. Is that okay, even though it's not first?
Commutative property says it's okay.
Ooh, so I can go in any order I want. So 5.5 times 7.5. We don't have to have our decimals lined up, but it just so happened that they're lined up. So 5 times 5.
25.
5 times 5.
25.
Plus 2 is 27. I can't forget.
Placeholder 0.
Don't forget them. 7 times 5.
35.
7 times 5.
35.
Plus 3. 38. And I add them up. I got 5. 11. 4. And I can't forget about my kids. Did I mess up?
No, I didn't want to forget the decimal.
Oh yeah, don't forget our kids in our car. I got 1 kid in this car, 1 kid in this car, so I need better have 2 kids in my last car. Oop, oop.
The back seat.
So 41.25, but I'm not done yet. I've still got to multiply by
22.
22. A lot of multiplying here, so be real careful. Okay, 2 times 5 is 10. 2 times 2 is
4.
Plus 1 is 5. Oops, that's not 5. 2 times 1 is
2.
2 times 4 is 8. And again, I can't forget my
Placeholder 0.
Okay, 2 times 5. Oh, look, I just get to do the same thing again. 10. 2 times 2, 5. 2 and 8. Then I add them all up. 0, 5, 7, 10, 9.
Oh, don't forget about the decimal.
Oh, yeah. Don't forget. Don't leave the kids in the car. Got 2 here, 0 here. So I should have 2 in my last car. Boop, boop. So my final should be, not area. This is volume. 907 and 5 tenths. And that is centimeters cubed.
Because it's volume.
Yes. Right there. Answer choice A.
All right. Elaine's dog pen is shown in the shape of a trapezoid. What is the area? So I'm going to use my N, F, S, S. I'm looking at my formula chart. Oh, wait, first I need to name the shape. This is a trapezoid. I'm going to name the shape as a trapezoid. I look at my formula chart. I don't have to memorize this. It tells me that the formula for area of a trapezoid is area equals 1/2 parentheses base 1 plus base 2 parentheses times the height. So now my S, I'm going to substitute. I'm looking at base 1. Have I already done this trapezoid?
I feel like we have. Maybe not.
23. I feel like we have. Okay, so for my substitute, I'm going to leave the A for area. I'm going to leave the 1/2. And for base 1, I'm going to say 23. Plus base 2, for base 2, I'm using this parallel length, 15. Base 2 is 15. And then my height is 9. Okay, so I'm going to do my order of operations. I'm going to start with this first.
Can I have 23 first?
No, because the order of operations says we have to do the grouping first. Since I have both the numbers, I'm going to do the grouping first. Plus, you don't even know what half of 23 is. Sure. So I've got 1/2 of 38. We have done this one. Times 9.
Oh, yeah.
Okay, so I'm going to half 38, which
19.
is 19.
I know that one.
And then do times 9. So I need some more room up here. I'm going to go over here. 19 times 9. Maybe our height was different, but I remember that half of 38. Okay, 9 times 9.
No, this was the same.
9. Yeah, 171. So when I put this in, 170. Oh, it doesn't like me. What did I do? 171.00, and it is positive. Can you put your hand on this and still it? Oh, that's what I was trying not to do.
Oh, no. You can
Yeah,
lay your arm all over
I
it.
can put my
Yes.
hand down. Oh, that's a game changer.
Okay, here we go. Kemp's gonna do number next, and it's gonna look beautiful. Okay, the area of this rectangle is 180, so it tells me all of this inside is equal to 180 feet squared, and it wants to know what is the height. Okay, it says based on the problem, we're gonna cross that off. It needs to say height. Okay.
So one fix with you.
Hey, we're doing pretty good so far. Only one fix. So I'm gonna do Nick Foster's silly stuff. Bam, bam, bam. Okay, the name of it, I want to say rectangle, but if I go to my formula chart, rectangle is not there. It's a parallelogram. It's got 2 sets of parallel sides. And I know the formula on my formula chart, again, don't have to have it memorized, is base times the height. Then I can go plug in. I actually have my area this time. My area is 180. I have my base, which is 8. But I don't have my height, so I'm just going to bring him down and leave him height. Oh my goodness, look what I made!
An equation!
Yay! Our favorite. So I get to box it,
Rail
it,
rewrite it.
whoop, whoop. Okay, so I always look for my variable, that's my letter, and I'm trying to get him by himself. So 8 is in the way of getting him by himself, and when 8 and 8 are touching,
It means multiply.
so I've got to do the inverse, or the opposite, which is
Divide.
divide. Whatever I do to one side, though,
I have to do to the other.
got to keep it equal. It's an equation. So 8 divided by 8 is 1. So 1/8 is just h equals 180 divided by 8. Okay, I'm going to do Ned Donkey, y'all's favorite. So Ned goes in the house, Donkey goes outside. 8 can't go into 1, but 8 can go into 18 2 times. 2 times 8 is 16. 18 minus 16 is 2. Bring down my 0. 8 can go into 20 2 times. Again, it's 16. I get a 4. Uh-oh, I'm out of numbers. I need to add a decimal and a 0. Bring down. And 8 times 5 is 40. So my height should be 22 5/10, which is D. And these shouldn't have little baby squares because they're just height.
Oh, another correction.
So that should just be centimeters. So we're just measuring the length.
We'll make sure to fix your paper before we print it.
Yes. Let me erase part of mine so you can see your problem this time.
All right.
Okay.
The area of a rectangle is 37.5 square feet. The height of the rectangle is 19. What is the base? If you need to, you could draw the beautiful little picture here.
Yay, pretty picture.
Pretty picture. And I'm saying that the area, so all of this space in here equals 237.5. And I have a height, so that's going to be over here on the side, a height of 19. It's 19 feet high. Okay, so now I'm going to use my strategy in F, S, so. Okay, naming my shape, they told me the name was rectangle. Uh-oh, I look at my formula chart and it says rectangle or parallelogram. Okay, so I have area equals base times the height. This time I know my area, so under A I'm going to put 237.5 equals. Under B, I don't know my base. It's missing, so I'm going to leave the variable B. But under H, I know my height is 19 feet, so I'm going to put that 19. Oh, look, this is a
Equation.
and I'm going to box it, rail it, rewrite it. 237.5 equals B19. How do I get that letter B by itself? I want this by itself. When a number and a letter are touching, that means
multiply.
I'm going to do the inverse, which is
divide.
Whatever I do to one side, I have to do to the other side.
Hey, and some of my kids look at the answer choices, and they know since there's a decimal in this top number, and there's not one down here, I'm probably going to have a decimal in my answer. So I could probably get rid of.
So smart. I'm going to get rid of
B and C.
and C. I love looking at the answer choices.
I
I need
know.
to do a better job of
Me
that.
too.
Okay, 19 divided by 19 is 1. So I got B isolated on the right. And on the left, I have 237.5 divided by 19. So I'm going to do my Ned Donkey, making the division house here. 237 goes in the house. 237.5. 19 goes on the outside.
Here's the roof.
Okay. 19 won't fit into, oh, thank you, Miss Neal. 19 won't fit into 2, but 19 will fit into 23 one time. And subtract. Bring down. Okay, 19 will go into 47. I'm looking at my answer choices. It's either going to be 2 times or 9 times. I think it's going to go in there 2 times. 2 times 19 is 38. So I'm subtracting and bring down. And 19 will go into there 5 times, which is 95. So 12.5 was my answer. Looking at those answer choices really helped. Okay, so I only have to fix one thing.
Yay, go ahead.
I know.
Wait, we haven't gotten to the part I did.
I know, we haven't gotten to it. Yeah.
Okay, so I'm just thinking should be bored.
Do it.
Okay. So Kramer will build a rectangle that has a length of 12 centimeters and an area, up to.
Ooh.
That's one of those key words with our inequalities. So if I say, Miss Kemp, you can have up to 5 cookies. Can she eat 2 cookies? Yes.
Mm-hmm.
Can she eat exactly 5?
Yes.
Yes. Can she eat 6?
No.
No. So it's got to be less than or equal to 60. Okay, so that's our key word. Square centimeters. Which inequality could represent B, the base?
Oh,
Okay.
Can we get rid of some because it doesn't match our inequality?
Yes, so I need less than or equal to. A is good. B is not good. It doesn't have the less than. C, not good. It's greater than or equal to. And D is greater than. So, oh my gosh, no math at all. Just knowing my keywords.
Wow.
Bam.
Bam.
There it is.
No bam.
No bam.
All right. So question
I like this.
next.
Ooh, equation.
Equation. Okay, I see this word right here. What value of x makes the equation true? So I'm going to box it,
rail it,
and rewrite it. I'm railing the equal sign. Okay, and I'm rewriting -70 equals -110 plus x. So I need x by itself right here. With the x, I have 110, -110. So I'm going to do the opposite of that, which is positive.
But there's an addition sign there, so shouldn't I subtract since there's an addition sign?
You would think that, but I could be subtracting -110, which would be the same as adding 110. This could also mean that this positive is for the variable, so plus x, a positive x. If I do plus 110 on this side, I have to do plus 110 on the other side. Okay, so a -110 and a positive 110 make a 0. So positive x, or x, is equal to, these are different signs, so I'm going to go over here and do my team positive, team negative. The negatives have 70 points, but the positives have 110 points. The win goes to the positives. And the difference between those two is 40 points. They're 40 points away from each other. So x equals positive 40 because the positive's 1. So B.
And be careful because look, there's a -42.
Yep. They're trying to trick you always and forever.
Tricky. Okay, which inequality is true when x equals 6? So remember when they tell you what a variable equals, our strategy is to plug it in, plug it in. Let's do it. We can see it faster, I can write it. Okay, plug it in, plug it in. So everywhere I see an x in these equations, I'm putting in 6. So on this first one, it's going to be -10. And again, when I plug in, like Ms. Kemp says, we're going to put parentheses there. 6 is greater than 60. So when I solve this, I'm going to go ahead and do 10 times 6, which is 60. And then I'm going to use Dorito Man to decide if it's going to be negative or positive. So I had a -10 and a positive 60, which leaves me with a negative. Good.
In my class, we also say they don't like each other, which makes for a negative situation.
There we go. So is -60 greater than positive 60?
No.
Absolutely not. A negative is never, ever, ever bigger than a positive. So A's out. Okay, B. Again, we're going to plug it in. Is greater than or equal to 60. Okay.
Hey, that's the same thing we just did.
Oh my goodness. I already know the answer is -60. Is -60 greater than or equal to 60?
No.
Still not greater than. Still negative and a positive. Okay. This next one, I've got positive 10 this time. Times 6 is less than 60. Well, this is just regular old numbers. 10 times 6 is
60.
60. Is 60 less than 60?
No.
No, they're the same. That's not true. Hopefully D's right.
Oh, come on, D.
10 times 6 is less than or equal to. Oh, I think this is it. I know 10 times 6 is 60. It's not less than, but it is equal to. So this is our right answer. Answer choice D.
All right, question next. We are looking at 1 plus 5 to the power of 4. So this little baby number is called an exponent. So I want to write this out, and I think about those exponents as being like a Nerf gun. And my Nerf gun is the brand of 5, so I have to put 5s in my Nerf gun. Those are the kind of little things that it'll shoot out. So I put in a 5 times a 5 times a 5 times a 5. And I know that it's going to shoot out 4 because of my exponent. And then I'm going to add this plus 1 here at the beginning. Okay. Now I see some operations, addition and multiplication, so I'm going to use handy dandy GEMDOS. Tells me start with groupings. I don't have any groupings. Exponent, I did my exponent, I wrote it all out. Multiplication or division, I've got some multiplication, so I'm going to start here. 5 times 5 is
25.
Times 5 times 5 plus 1. Okay, still have some multiplication, so I'm going to do this multiplication. 25 times 5.
125.
125 times 5. I'm going to copy that down. I still have multiplication, so I'm going to do 125. I don't know this multiplication fact. Times 5. So 5 times 5 is
25.
5 times 2.
10.
Plus 2 more.
12.
5 times 1.
5.
Plus 1 more.
6.
So I've got, this is 625. I still have that plus 1. So my last step is to add 1. 626. C is the correct answer. Okay, question next.
Almost there. Okay, yesterday 180 students wanted chocolate milk at the lunch, and 220 students did not want chocolate milk. What percentage, it's asking for a percentage, of the students did want chocolate milk? So when I'm asking for a percent, I'm always going to do fraction bar equals fraction bar. And again, it's always part over whole equals percent over
100.
Okay, so I don't know the percent. I do know the part that did want chocolate milk, right? It told me up here. 180 students wanted chocolate milk. So that's my part of the kids that wanted chocolate milk. Okay. Ooh, my whole must be 220 because that's the only number there. No, because that's whole students, right? 220 is just the part that did not want it. I have to add my chocolate milkers in there. Oh, what did I do? I erased it. I have to add the chocolate milkers and the non-chocolate milkers. So I got to add 180.
Do not want chocolate milk.
I don't know. It's the best. Plus 220. 0 plus 0. 0. 8 plus 2.
10.
1 plus 1 plus 2.
4.
So that is my
400
whole.
students.
Okay, always got to add those together. Don't just assume the other number is the answer. Okay? There's 2 ways we can do this. The old way, we can figure out how do I get from 400 to 100, which would be, I think we could do it this way. I'm going to divide by 4. Okay, and whenever I do on bottom,
have to do on the top.
I'm going to divide 180 divided by 4. So that's my Ned. That's my donkey. I'm going to come over here, put Ned in the house, donkey outside. 4 can't go into 1, but 4 can go into 18. Go in there 4 times. 4 times 4 is 16. 18 minus 16 is
2.
Bring down. 4 can go into 25 times, which is exactly 20. So my answer is 45%. And if it didn't work out pretty like that, remember you can always cross multiply 180 times 100 and then divide by the 400 if you needed to.
All right.
I don't know what that little extra greater than sign in there is.
Okay, another fix we need to make right
bonus.
there. We're fixing this little guy right here. So that's not too many fixes we have to make.
No.
Okay. The class earned cupcakes as a reward.
Whoop, whoop.
Ooh, your incentive day will be on Friday, so think about rewards. All cupcakes are either chocolate or vanilla. The ratio of chocolate cupcakes to total number of cupcakes was 12 to 26. So I want to make sure I'm doing this right. It's talking about cupcakes to total. So when I see this word 2, that's my colon. So I've got cupcakes, chocolate cupcakes. Oh yeah, chocolate cupcakes to the total. So this first number, 12, is my chocolate cupcakes. To the total is this number here, 26. Okay, so that's my ratio. And they want to know which number could be the number of vanilla cupcakes. So I'm going to do my UKSN. Okay, and I know that we're talking about vanilla And we're talking about chocolate.
We need a total
and
line.
a total line. Okay. So I know that my chocolate was 12. So by the C, I'm going to put a 12. I know that my total was 26. So in my total line, I'm going to put a 26. Oh, now I need to find the vanilla. This is where Mr. Kemp would say, use your brain. Okay, so if I have a total of 26, 12 of them are chocolate, subtract, so 14 must be vanilla. 14 plus 12 is 26. Yep, I'm good to go. Which number could be vanilla? So we're looking at this right here. On a number that could be vanilla. So I need a multiple of 14. So let's see. I don't know my 14, so I'm going to do 14 times 2 is 28. That's not a choice. Okay, I'm going to do 14. Could have also done a hashtag, I guess.
Sure.
Times 3. Let's see, 12. 42.
Oh, I see it. I see
That's a choice. Okay. I know it can't be 60 because that's 5 times 12, so it's not that. These are not correct. So I'm looking for 42. It could be 42.
Yeah, I bet there's multiples of 12 and 26 on there as well.
Oh, yeah, they're trying to trick us.
So always know what you're asking for. It's asking for vanilla. Okay, which two expressions are equivalent?
Oh, this is the last one before we do this. Your catchphrase for candy from your math teacher is, oh my gosh, I'm a genius, I watched the video. Oh my gosh, I'm a genius, I watched the video.
Don't share it with your friends. If they didn't watch, they don't get candy. Okay, so which two expressions are equivalent? So if we look at A, okay, and if I did my order of operations for this first equation here, it's got these, I guess I'll write Jim Doss up here. It's got parentheses, so I know I have to be adding 5 plus 6 first. That's going to be the first step.
Oh, that makes me think of the one with the pool, the swimming pool, and the lifeguard.
Yes, the lifeguard. So this guy's the lifeguard, and he's got to save every single person in the pool. Okay, so 8 times 5, he saves them by multiplying, is 40. And 8 times x, I'm just going to leave it 8x, which also means times. And then I'm putting my sign back in.
Yeah, the floaty.
Yes, the floaty. So we've got 8 times 5. Check. That's what we did here. And then I've got 8 times x, which check. That's what we've got here.
Oh,
and
my floaty.
My floaty's good too.
Yay.
So this looks like this could be it. Let's put a question mark. Okay. This guy. This one wouldn't be
lifeguard because it's not touching.
Yeah, we've got that little plus sign there. So I would just be multiplying 7 times 8.
That's the first step, yeah.
Which is 56. So this would be x plus 56. And I really can't go any farther than that because they don't have the same last name. They're different. I can't combine x's and 56. So that's as far as I can go. But on this one, if I do this first, x plus 7, I really can't go any farther than that. But I could do the lifeguard, even though they aren't touching. I know that when they were touching, that was parentheses. So I'd multiply it out. And I've got 7 times 8, 56. 8 times x is 8x, and then put the floaty, the plus sign back in. And it's not the same because of the x and the 8x. They're different. He's out. Okay.
Bye-bye, B.
Bye. Okay, this next one, again, if I were to do order of operations, I'm first going to multiply. 7 times 5 is 35, and then I've got 35 divided by x. And again, that's as far as I can get. Okay, this one, again, I'm going to multiply first. 7 times x would just be
7x.
7x divided by 5, and again, I can't go any further because I don't know what x is, and those are not the same. I see. And then number last, again, we're going to multiply first. 5 times x is
5x.
And then plus 2. And again, that's as far as I can go. They don't have the same last name. They are not like terms. And then here, again, I'm going to do the lifeguard.
Oh, yeah.
So I've got 5x. And then 5 times 2 is 10. Put my floaty back in.
Oh, that's
Uh-oh. This is a 2 and this is a 10.
No.
So our correct answer here was
A.
A. Oh.
We
Well, I have one more.
have one more.
One more. Take us
Is that,
home, Kim.
oh, wait, is that the one more in movie?
Yes, that's.
There's 2 with distributive property? Okay, so sorry. All right, so sorry, 6th grade. All right, here we go. Distributive property, or actually it's Jim Doss again. So which expression is equivalent to 40 divided by x plus 4? So I'm going to use my Jim Doss. Okay, it tells me to start with my groupings. So I would start with this. I can't really change x plus 4, but I'm looking for that to be my starting place. So I'm going to A. In A, I'm going to underline my starting place. X plus 4 is my starting place. So that's looking good. Okay, I'm going to go to B. B, my starting place, is x plus 4. That's the same as 4 plus x. They just turned it around with the commutative property. Okay, and C, I'm going to do, my first step would be 4 divided by 40. Oh, look at that, 6th grade. That looks like this. That's going to be a fraction. No, I don't want C. I'm getting rid of C. Goodbye, C. Okay, and then in D, my first step is going to be this division because it comes first. And that doesn't match what I'm doing first, so I'm getting rid of D. So I've got a 50-50 chance here. The second step is going to be 40 divided by, A is showing divide by 40. So they're starting with 4 plus x. But here they're starting with 40 and dividing by. So A cannot be it. B, they're starting with 40. That's good. We can't move that 40. When we have division, we can't change the order. And they're still dividing by the same thing. They just use that commutative property to turn it around, which is allowed. X plus 4 and 4 plus x are the same thing.
Whoop, whoop.
Whoop, whoop. You've got this, 6th grade.
Study hard.